So these results are useful when we want to find the zeros of cos, sine, cosh and sine. So what do we mean by zeros? Simply the values of z such that cos z is 0. So if we try to solve this, cos z equals 0, then how do we get 0? Well, it's only going to be 0 if both cos x and sine y are both 0. Remember, x and y are real, so there's these have to be both non-negative. So this implies that cos x is 0 and sine y is 0. Sine y equals 0 has only one solution, which is y equals 0. So it has to be real. Okay, so the only zeros of cos are real, and we already know what they are. Cos x equals 0 implies that x is n plus a half pi, where n is any integer. Obviously, sine z equals 0 is going to give the same sort of thing. Sine z equals 0 again will imply that y equals 0. We have to have the only solution to sine y equals 0 is y equals 0, and again we get the solutions we expect. So sine x equals 0 implies x equals n pi for any integer n. Now for cosh, well, here we must have x equals 0. So if we look for solutions of cosh z equals 0, we know that x has to be 0. And really it's just the reverse of what happened with cos. Now we know that y, cos y is 0, which implies that y has to be n plus a half pi. Now remember, z is equal to x plus I y, so the zeros of cosh are z equals I y, which is n plus a half pi I. And the zeros of sine, similarly, sine z equals 0 implies x is 0 and sine y equals 0, which means that y equals n pi, and the zeros of sine z equals 0 are simply n pi I. Okay, so these are very important results, so just put them in. These ones we know already. So notice that cos and cosh, cos and cosh are very are related. The zeros of cosh are the same as the zeros of cos, except they're rotated 90 degrees. In other words, you multiply the zeros of cos by I and you get the zeros of cosh. Similarly, the zeros of sine, if you multiply by I, give you the zeros of sine. So pictorially, these dots represent the zeros. So the zeros of cos z lie along the real axis. The zeros of cosh z lie along the imaginary axis, and we get one from the other just by rotating 90 degrees. Similarly, the zeros of sine z, as you know, lie on the real axis. The zeros of sine z lie on the imaginary axis. You get those by rotating 90 degrees. So this is a very useful picture to have to remember.